Hello, everyone. Thank you for joining me today on this beautiful Saturday in September. So I know we're not covering the most glamorous of topics and aspects of landscaping, but irrigation is definitely one of the most essential parts of our landscape, especially now that we had such a hot August. I know I've seen a lot of the effects of poor irrigation practices. So today we're going to be talking about advanced home irrigation and troubleshooting. We're also going to be talking about maintenance. And just a reminder, if this is your first time or maybe you're not a seasoned veteran with Zoom, we have a couple functions I wanted to cover before we start. So we have a Q&A. So anytime you have a question that comes up during this presentation, please put it in the Q&A, which I could make sure that I answer every single question that you have. This is going to be a little bit more in depth than the standard show and tell of irrigation sprinklers. And so we're going to go over a lot of processes for repair and troubleshooting. So any questions, please put it in the Q&A. There's also a chat function. I'll do my best to look at both, but definitely if you're able to put something in the Q&A, I will definitely make sure we cover that. And so this is a series, this is a presentation in a series of webinars we've been holding at the WaterWise Community Center, where all the presentations, if you go to cbwcd.org/presentations, you'll find a PDF of this presentation, as well as we've gotten over double-digit presentations now. So a lot of good content on there. And then we're also live streaming on YouTube. You can find the playlist for all the webinars that we've hosted these last couple months at cbwcd.org/YouTube. That'll take you right to that page. And since I cannot see or talk to you all, I'm going to do a opening poll and a closing poll just to kind of get a feel of the virtual room. So I'm going to go ahead and launch the first poll. If you could be so kind as to answer some of those questions, greatly appreciated. So we had one question, if there's going to be a PDF or an equivalent of this presentation. The answer is yes. So sometime early next week on cbwcd.org/presentations, you will find a PDF of this, as well as if you want to review the live. Okay, it looks like most of you were able to do the poll. I thank you. So I'm going to go ahead and close out the poll. So first question, how many people are watching with you today? So not surprising, vast majority is just them by themselves, a few of you and another person. So welcome everybody. Thank you again for supporting our programs. So almost about 50% is your first time, so welcome. We're always happy to have new people, and we're very thankful for the return, people that return to our programs. So we have actually the majority outside of this area. So in the chat, we say Orange County, Walnut, Orange County, Northridge, Henderson, Nevada. Nice. San Diego. Welcome, everyone. Thank you all for being here. So with that, we'll go ahead and start the presentation. So a little bit about what we do. So we're the Chino Basin Water Conservation District, also known as the Waterwise Community Center. Um, and our main mission is to sustain regional water supply through public stewardship with engaging in the following strategies of demonstrate, educate, and percolate. So what does that mean? So just to give a little bit of context, so this is the Santa Ana River watershed where our boundaries for our water conservation district lie above the Chino Basin aquifer. So the larger Santa Ana River watershed has multiple groundwater storage areas where we're located over the Chino Basin. Aquifer is the largest in that area, where we pull over 50% of our water is actually pulled from this underwater aquifer. So for us demonstrating, so we have over a 4-acre demonstration garden. This class would be hosted there, but I'm right here in this little building right here as we speak. But here's an overview. You can see these are our infiltration basins, and here's our demonstration garden, as well as a park for the public. So that's where we demonstrate. So we don't just talk about it, we actually have a place for people to come and see what we're talking about. And then education. So my programs, we deal with conservation programs. So we talk about transforming urban landscapes into sustainable, beautiful spaces. Also web resources. We have a website called the inlandvalleygardenplanner.org, where we have about 400 climate adaptable plants for you to learn and understand irrigation, maintenance, what time of year they flower, and then also groupings together, we can help create palettes. So great resource. And then percolation. So I always like to show this slide. In the natural environment, we have only 10% runoff to streams, and we have over 50% of infiltration. Low is good for the plants and deep to replenish the aquifers. But now we have a lot of urban areas where over 55% is actually is runoff due to the impermeable surfaces. So we see a lot of these. Right, storm channels. So this is to redirect a lot of storm runoff, and it typically puts it down into the ocean. However, Chino Basin Water Conservation District, we own 8 percolation basins. So these look like big open pits. Sometimes they're full of water, sometimes they're not. But what we're actually doing is trapping that water and letting it percolate down to the groundwater. So here's just couple stats. So if during the winter, multiple times we almost have a full recharge, that's almost half a billion gallons of water that's stored and put into the aquifer. And we're very much engaged in our community, whether it be K through 12 events, higher education, families, professionals, classes like this. So why am I here talking to you about irrigation? Well, I blame my parents. My parents have owned and operated landscape tree care as well as landscape companies since I was a young child. So this is really the only job that I've ever had. And there's the proof, dirty face and working. And I focused on irrigation I want to say like early on. I liked the technicality of it, doing commercial sides, figuring out the piping size, troubleshooting the problems and the issues that would arise. After that, for about 3 years, I was just, my primary source of income was I was an instructor. So this was Irrigator Technical Training School. And I traveled around with this huge trailer and it was full of parts, and we would teach classes for contractors, cities, schools, institutions. But overall, I just love nature. I'm a big proponent, big nature nerd, whether it comes to this is Bristol cone pines. Some of the oldest living trees. I try to go to a lot of outdoor places like that. And with that, we're going to go over what we're talking about today. So overview the irrigation system, tools of the trade, how to conduct an irrigation check, common irrigation issues, and understanding the maintenance. Right, so this is the reason why we're here. Pictures like these. One of the services that we have on hold, but we do conduct in my program is we do a landscape evaluation and audit program where we go to residents and we do a consultation for them and find any issues and help and do a report for them. So a lot of these pictures, I took the majority of these pictures. Right, so we're going to briefly go over the irrigation layout. About a month ago, I did the irrigation, basic home irrigation class. So that is on demand, whether on YouTube or on our website with a PDF of that. And I cover every aspect and detail of the landscape in the irrigation system. We're going to briefly do a little intro to it just to give context, but we're going to be focusing more on maintenance and repairs that we might need to undergo. Right, so where can irrigation fail? Basically anywhere. These are plastic parts, these are electronics, they do go bad over time, just like everything else. So why should we care about irrigation so much? Again, it's not the most glamorous aspect of landscape. Let's see why. So 3/4 inch PVC pipe, which is typically the standard size pipe for residential irrigation, can flow up to 14 gallons per minute. Right, so when there's a break, we can flow up to 14 gallons per minute from that pipe. A lot of that water is underground, but you can see when we have irrigation run times of 10 minutes to 15 minutes, depending on the type of sprinkler we have, 14 gallons per minute, it can really add up. And if going unnoticed, can really rack up the bills. On average, a broken sprinkler can waste up to 9 gallons per minute. So if we have a completely broken sprinkler, water can flow up to 9 gallons per minute out of that. And then an irrigation zone with 10 sprinklers operating at 20 PSI higher than ideal pressure can put an extra 100 gallons of water per week, with the majority of that water running off site or down the street. So we're going to cover pressure and how that matters. So areas that have high pressure, the irrigation, especially the pop-up sprinklers, will be misting, and a lot of that water is wasted because it's running off and going down the street and not on the intended plant material. So this is a very hands-on class that when I teach it here at the WaterWise Community Center with a lab. So what I did is I created a series of videos that we'll see throughout. And this is the first one. So we're going to start with doing an irrigation check. In this video, we're going to be talking residential irrigation. We're going to cover the 5 steps to completing an irrigation evaluation that you can do at home. Step number 1 is check the water meter. Residential water meters are located at the curbside of the residence. A handy tool to have around is a rag so we can wipe down the faceplate or the odometer of the water meter. The reason why we want to wipe down this odometer is we want to look at the readings. As long as there's no water running inside the residence, we can look at the leak detector as well as the odometer. If we see any movement on that dial, that's indicating that we have a leak. Looks good here. Step 2, walk the landscape area and look for issues. So during our walk, we want to have a notebook handy where we can take notes. I like to indicate the areas doing the irrigation check, the date, and the possible issues. And what we want to look for is areas that seem to be overwatered. Here we found an area that is brown, that is dry, indicating not enough water. Want to make a note of that. And another area we want to really look at is the shrub area. Shrub areas tend to be overwatered, so we want to really look in and see if there's any areas that we could be saving water. Step 3, locate the irrigation controller. Though not all irrigation controllers are located in the garage, at our site here, that's just the case. It can also be installed on a wall or anywhere that they have power available. Once we locate the irrigation controller, I like to make sure that the date and time are accurate so our program works correctly. There's some other features that we can look at on our irrigation controller, like start time, when our irrigation is going to start running, how long each zone is going to run, and how often, or how many days our irrigation is going to run for this week. A great thing to do when you run your irrigation system is to write each zone and where they're located in your residence. Once we have that, we know the areas that we want to look at based on our walkthrough. So we have the zone and the area to do it. Step 4, perform a test of the irrigation system. So as we turn on the irrigation system, it's best to give it about 5 to 10 seconds until the zone is completely pressurized. We want to walk around and check for any inefficiencies. We want to repeat that again from zone to zone. So this one here, we seem to have some issues with runoff, as well as a sprinkler that's not only clogged but tilted. Here's an example of a broken rotor. The seal's broken, as well as another sprinkler that's turned and tilted. A pro tip, you can manually turn on your irrigation system at the irrigation valve. By simply turning the bleed screw 1/4 to 1/2 a turn, your irrigation system will turn on. This will allow you to walk the site for as long as you need, check out any inefficiencies, and when you're ready to turn the irrigation valve back off, simply come back to the bleed screw, turn the knob till it's tight, and the irrigation valve will turn off. Step number 5, review field notes and make necessary repairs and adjustments. Here are my notes. 3 broken sprinklers. Looks like I have a lot of work to do this weekend. Okay, so now that we know how to do an irrigation check, let's go ahead and talk about the tools that we're going to need. Okay, so tools. So starting with trenching shovels. So there's multiple widths. So when we're talking about the inches, we're talking about the width of the shovel here. So in this one is the blue, which is good for detail work and digging in small spaces. So this is a 3-inch. Handy one to have, especially in small areas and doing a lot of detail work, like I said. And then one of the standard irrigation repair shovels is the 4-inch, which is an orange. Good for digging, gets you a big enough hole while still small enough to get in those smaller areas. And then the red is a 5-inch, typically used to dig trenches for irrigation repair. So that wider part of the shovel helps you do more digging with less effort. And then the 6-inch is a large shovel, again, for mostly for doing digging for installation and digging large areas. Those are the trenching shovels. So those are designed to either dig trenches or dig mostly piping or dig out a sprinkler or valves. Now we have digging shovels. So we have a spade shovel, the utility shovel, great for digging, really good in rocky soil, and a square shovel. So you can dig with a square shovel, but it's mostly for shaping, smoothing soil. trying to, if you're going to be doing any kind of planting or trying to true up your trench, that nice straight edge will give you a nice smooth and even trench. And then pick, so I put a pick Maddox. This is good for working in hard soil solutions or situations, helpful when trenching for irrigation installation as well. When you have a lot of rocky, a lot of hard soils, especially with irrigation installation, definitely having a pick with both sides, either the sharp side or the more or the flat side, gives you that option to really break up that soil and help you out in most situations. And then pipe cutters. So a lot of these tools, I took these pictures. These are the ones that we have in our shop, so you can see they've been well used. But we have the ratcheting PVC cutters. These are heavy duty. They are pricey. You can get them at any big box store. This is Victor cutters. These are more commercial. You can get a replacement blade, so they will last quite a long time. And they come in 2 sizes. Most of them do. They can come in multiple sizes, but we deal with primarily 2. The smaller one does 1 inch or half-inch pipe up to 1 inch. So at a residential property and in most garden situations, up to 1 inch is about the biggest you would need. So when I say half-inch to 1 inch, that's the opening here. That's what size pipe can actually fit in these cutters. So anywhere from a half-inch to 3/4 to 1 inch pipe can be cut with these cutters. And then the larger one is about 1.25 to 2 inch pipe. They do go larger than that, but they get a little bit tough because you do have to ratchet and cut through the pipe. And so there's other options. There's pipe cutters, so you can have hand saws. The orange handle is specific for cutting PVC. And if you have to have a little bit of extra room in this, and you want to make sure when you're cutting pipe, especially to make a nice even cut. For small areas, let's say you have a pipe that's surrounded by a bunch of tree roots, or and you don't want to disturb the roots of the tree, or if you just have a really tight area where it's really hard to dig, one of these cable saws work really well. You have 2 handles, and you basically use a saw motion. You put the cable underneath the pipe and then just saw back and forth, and it'll cut through the PVC pipe. And then lastly, this is for cutting drip tubing. So there's larger tubing and smaller tubing, and just one blade. This tool comes in handy when working with drip irrigation. So for hand tools, some tongue and groove pliers, which are these here that are adjustable. These are channel locks. A lot of people refer to all tongue and groove pliers as channel locks, but that is a name brand. So if you know channel locks, these are adjustable pliers. They come in multiple sizes, so a smaller size and then a larger size would be all you would need for irrigation. And then wire strippers, they come in really handy. We're going to cover a little bit about wire nuts and the importance of connecting the valve properly electrically. So stripping the wire, putting wire nuts on, cutting wires. So that is definitely part of irrigation maintenance. So light electrical work. As a contractor, you're not allowed to touch the 120, so the power going into the socket. You're only able to work after that. So if you have an irrigation controller, usually at home, it's a pigtail where you plug that into the wall. And so it's all low voltage relatively when it comes to irrigation. And one of the most important tools of the trade is PPE, or personal protective equipment. Safety glasses, really important, whether we're wielding an axe or we're using a shovel. We have gloves. Gloves are always important to have. Keep your hands from keep your hands from wear and tear, blistering, especially if you're using a shovel all day, as well as digging. Um, Definitely good to have a pair of work boots. Work boots keep you keep your toes safe, your ankles, and always have a good pair of work boots. And then a mask, dust mask to keep dirt and debris and other contaminants from breathing in. So now we got the tools of the trade. I want to start with checking the water meter. In the video that we watched with the irrigation check, it talked about checking the water meter. So the water meters are typically located by the street, indicated in usually a concrete box. I'm seeing some of the utilities in our area do more irrigation box, so plastic boxes. I'm not going to talk about it too much, but what I want to talk about is we can check for leaks with the water meter. So again, this is what the box usually looks like. This is outside of our facility right here. So this is a much larger meter than most. Typically, this is what you'll see in most residential or even commercial. A lot of buildup of soil. So you want to get in there, dig around, and clean out. So I said we can check for a leak. So how could we do that? So checking for a leak. So different water meters have different leak detectors. So here's 3 options. Sometimes it's a triangle in the corner. This is a paddle wheel. This is the center of the odometer. So this will turn. So what these leak detectors detect is low flow leaks. So what's a low flow leak? So let's say we have, for instance, when it comes to irrigation, let's say our irrigation valve is leaking just a little bit. The water meter dial, it's not going to turn with very low flows. What you're going to find is this little indicator is going to be moving very slowly, right? In all of these cases, if you have a leak, mainline leak, so in the main piping before it goes to the irrigation valves connected to the water meter, if there's a leak there in an irrigation situation, the leak detector will be moving. I've gone to a lot of houses with issues like this, and I've even seen it where somebody has a hose bib way in the back of their property. They open it up every once in a while, use it, and they close it, but this time they left it cracked open, and now their water bill went up 4 times because it's just a constant leak, and it's all the way in the back of the property. You're able to go in and look at that leak detector. Could be the same as you have a leaky faucet in the house or a leaky toilet. You would be able to see that low of a flow by this flow indicator. So how do we check? So if we're worried about irrigation, that there's an irrigation leak, we want to make sure there's no water running in the house. So that means no dishwasher, no clothes washer, nobody's using the bathroom. Make sure everything's off. Locate the water meter, open the box, and clean the odometer. So this is the odometer. Like again, typically it's a little hard to see, cloudy, maybe a little dirty, so wipe it down. If the leak detector moves and it persists, then that means that you have a leak. So really great tool and easy to check. Okay, so now we're going to talk about the piping. Right, so you can see here we have one break in the lateral line. So when the sprinkler system goes on, again, this could flow upwards of 10 gallons per minute. All this water is coming from all the way back by the front. Not only is this a poor irrigation practice and we're wasting water, but we're also causing damage to the concrete, as well as potential slip hazard. You can see there's quite a bit of water. Just like this, water is just coming up out of the ground. And there are a lot of indicators, weed indicators, that show you that something's being overwatered or that there's essentially a break, I usually find. See, this is all Bermuda grass that's growing up through the shrubs. this has to have been broken and leaking like this for a long time. Now, this was a commercial site. It wasn't necessarily a home. Typically, if you have this much of um, water leakage in a home, you would find out unless you have a large property, but um, this had to have been running for months. Broken underneath the ground. So when this station came on, water comes up through the seam here where the driveway meets the sidewalk. A lot of water seeping through there. And so the different types of irrigation piping. Drip tubing, so we're going to cover drip towards the end of this presentation. We have PVC fittings, so everything from a cross to a 45 to a 90. You have to do sometimes a little bit of engineering to figure out what parts you need. We have PVC piping, blue lock pipe. So this is a piping system that's sort of a mixture, you could say, on the surface level at least. The difference between drip tubing and a PVC pipe. So it's malleable, and it's called poly tubing, and it uses glueless fittings. We use it here at the garden. I usually demonstrate it when we can walk around, but also an option. A little bit harder to find the parts. And when it comes to PVC piping, we have two different types of PVC piping. So these are both 1-inch pipes. You can see there's a difference in thickness. So that's a Schedule 40 pipe on the left and a Class 200 pipe on the right. So both will work with 1-inch fittings. It's the inside diameter that's different, not the outside. So why is there a difference in the thickness? So for Schedule 40, the thickness is going to stay the same no matter what size the diameter of the pipe. So as this pipe gets larger, the overall thickness of the wall, the pipe, gets smaller. So the pressure rating starts to drop once it gets around 1.5 to 2 inches. Whereas Class 200 has a PSI rating of 200 PSI, no matter if it's a 1/2 inch, 3/4 inch, all the way up to, a 6-inch pipe. Class 200 has a pressure rating of 200 PSI. So class is constant. There's also class 350. So it's 350 PSI, no matter what the size or the diameter of the pipe. Whereas schedule, the pressure rating on a 1-inch pipe, Schedule 40, I want to say is around 300, probably 350, just off the top of my head. So really high pressure rating. Our irrigation system should be running less than 100 PSI, hopefully closer between 75 and 50 PSI. So that's kind of overkill, but it's a much sturdier pipe. So in residential, over time, the Class 200 becomes brittle and breaks. So just wanted to cover that a little bit. So for repairs, I'm not sure if any of you have glued or used primer to repair PVC, but I wanted to cover it. I usually do a demonstration, but I wanted to talk about the process of it, and then I really wanted to cover the safety aspects of it. So starting with the primer. So the primer strips and softens the PVC pipe and the fittings. First step in the gluing process is to prime. Dries quickly, less than 10 seconds in most cases. The available brands are Weldon, Odie, Christie's. So any big box store you can get any of these brands. So what's the process? So the priming process is you apply a coat of primer to the pipe, apply a coat of primer to the fittings, and then allow to dry before starting the process. So this again is just going to kind of eat a little bit of the enamel and soften the pipe to get it ready for the joining process. And so the PVC cement, so this connects the pipe and the fitting together. Relatively fast setting time, so half hour to 1.5 hours. You want to wait a minimum of 1.5 hours before you charge the irrigation system. I tend to wait a lot longer than that. Manufacturers' specifications will tell you the set time. I know that this brand in particular, Christie's Red Hot Glue, it says that it'll set in 30 minutes and you can turn the water back on. If I'm doing all the work and digging this out and putting it together, I want to wait a little bit longer if I can. Steer and mix before you use it. Discard if it gets jellied. So if the glue starts to get kind of hard, it's not as liquid, just get rid of it. Get rid of it in the proper way. So it is hazardous. Read the label to see how to discard it. So that's why I usually do, like at my home, I have a smaller a 1/4 pint size. So it's a lot smaller of a can. So I know that, maybe I'm going to do some repairs throughout the year, and that's going to last me probably a year. It would go bad otherwise. Same thing with the primer. The primer will evaporate because it's acetone. So buying those smaller ones, if you just want to have them handy at your house, is a good investment. The bigger the can is, the more likely that it's going to go bad unless you're using it quite frequently. So the gluing process for using the glue and the pipe is we apply a coat of glue to the pipe. We apply a coat of glue into the fitting, and then we apply a second coat of glue to the pipe. So we hit the pipe twice, we insert the fitting, and then we twist the pipe a 1/4 of a turn. So we want to do a 1/4 of a turn to make sure that all the glue is sealed around the fitting. And then you want to hold it in place for about 15 seconds. And then repeat the process if applicable. So if we have another piece to do, that's the same process for every time we glue a joint. This is the process. Coat of glue to the pipe, coat of glue to the fitting, second hit of glue on the pipe, and then put the piece together, 1/4 turn, hold for 15 seconds. So here's where I wanted to cover a little bit. So just like with any chemical, there is a safety data sheet. So I went and downloaded, this is actually 4 pages. I'm just focusing on the first page here. So it tells you everything you need to know, acute toxicity, skin irritation category, eye category. So the lower the category when it comes to health it's more dangerous. But I wanted to focus on section 2, especially the hazard statement. So it says highly flammable liquid and vapor causes serious eye irritation. I do not recommend ever using this without wearing your wraparound safety goggles. I know plenty of people in my years, seasoned veterans that have glued things for 30 years and they just open up the can and then a little bit flicks up into their eye. Serious eye irritation. Please be careful using this. May cause respiratory irritation, may cause drowsiness or dizziness, suspect of causing cancer, may form explosive peroxides. So precautionary, so keep away from heat, spark, flames, avoid breathing the dust, gas, mist, vapors, wear protective gloves, protective eyes, protective clothing, face protection, get medical advice attention if you come in contact in your eyes or swallow it for any reason, and store in a ventilated container tightly closed. So I hope I didn't scare anybody away with that, but you just have to be safe. That's all I'm getting at. Respect when we're using chemicals. So again, I have a short video again of the gluing process, but basically we cut the pipe, put the primer on the glue, Put the glue in the fitting on the pipe. Always have a rag handy, you can wipe excess glue. And with that, I have 2 short videos of the gluing process and cutting pipe in lieu of our lab we would be doing today. So I'm gonna check after the video is done to see if there's any questions thus far and go from there. So if you have any questions about anything we covered so far, please put it in the Q&A.
Hi, this is Brandon with the WaterWise Community Center. And in this video, we're going to break down the steps on how to repair PVC pipe. Just like with every job, we need to have the proper tools. So for repairing PVC pipe, we need an irrigation saw, a pair of PVC cutters, tape measure to measure the pipe that we're going to be replacing. And in particular, when dealing with PVC pipe, we need to use a PVC primer. I have 2 separate types of glues here. This one is blue glue and this is clear glue. Both do the same thing. Most important of all is your personal protective equipment. So you need a pair of safety goggles. And since we're using a solvent, you want to wear some sort of leather or rubber glove.
In this video, we're going to be talking residential irrigation.
Hi, this is Brandon with the
We're going to cover
WaterWise
the 5
Community Center.
steps.
And in this video, we're going to
irrigation.
break.
Oh, okay. There we go. Sorry about that. Step 2.
So when cutting your PVC pipe, you want to make a nice smooth cut. So the first step in repairing PVC pipe is you need to apply primer to both the pipe and the fitting. So when applying the glue, you want to apply glue to the pipe, to the fitting, and again to the pipe. And then you want to put the fitting and the pipe together, doing a quarter turn, holding it for about 10 seconds.
Okay, so you can see how messy that got with me, and that was on a table. So here's just a couple examples of repairs. So this was a section that needed to be repaired. We had 2 T's, purple pipe indicating that this is a reclaimed water system. Now, I'm going to talk about repairing with a Slipfix fitting. So the example I'm showing is a glueless fitting, but the gluing process would be the same. So here we needed to replace this T. So the T breaks. So I want to say, unless there's some sort of intervention like a tree root breaking a pipe or rocks just tearing away at the pipes over time, you're going to be leaking on your pipe system at a fitting. Either a 90 at a T, someplace where it was glued and somehow came undone. So this was a repair that needed to happen on this T. So when you go in with your cutters, either you can use your cutters, your handsaw, you want to cut as close to the fitting and as straight as possible. So here's the Slipfix. So this is a telescoping fitting, which this part can retract and become smaller so we can fit in the area and then extend to make the seal and make the repair. So when you cut the pipe, you want to let the pipe sit for a while, depending on how large your zone is. Water is going to drain out, and you want to make sure all the water is drained out after you cut the pipe. You want it as dry as possible for the primer as well as the glue. You can see there, you want to clean, make sure it's nice and straight cuts. So you would glue the edge of the Slipfix on, so the same gluing process, primer on the pipe, primer on the fitting, gluing process of glue on the pipe, glue on the fitting, glue on the pipe again, put the fitting in and rotate. So this is, again, it's telescoping, so it is going to fill that gap, so you need to measure the gap before you cut it. And there you go, this is the fitting. So we replaced the T here. We had to replace a section of the pipe. So this fitting is, that fitting is repaired. So for maintenance, when it comes to pipe, thankfully there's no ongoing maintenance. Your irrigation piping is underground. Basically, if there's an issue when it comes to making a repair, of course, we'll have to investigate. We'll have to dig up an area that seems to be overly saturated. But as far as maintenance goes, no said maintenance for irrigation piping. Put a break session in here. Do we have any questions? Does not look like it. Okay. Okay, I'm gonna go ahead and move on. We could take a break a little bit later. Still have quite a bit to cover. Okay, so irrigation control valves. And since we're talking residential primarily here, these are anti-siphon valves. So the state of California requires that per the plumbing code that we have irrigation control valves. They need to be installed, or anti-siphon irrigation control valves that have an anti-siphon aspect, and they need to be installed a minimum of 6 inches higher than any outlet of the water, so any sprinkler head. So the water is not able to backtrack or siphon into the public water system. That's why we have irrigation valves like this. Again, we go more in depth into how valves work in our irrigation basics class. Here, I just wanted to hit a couple things. So a manifold is a grouping of valves. That's the terminology. So if we see this here, this grouping would be called manifold. They operate off of electrical signal that runs from the irrigation controller to the solenoid. Requires 24 volts of electricity or to activate this irrigation control valve. There are battery operated units. I'm not going to talk about them today, but they do have a battery operated irrigation controller that would have to have a replacement solenoid, and that's a DC latching solenoid or solar powered solenoids. So we want to talk about terminologies again. So again, the solenoid is the electrical component. It's identified by 2 wires coming out. The flow control, which is the upper part of, or it's the handle on the top of the bonnet, which is the upper portion of the valve. And again, this is an anti-siphon valve. So this is an anti-siphon component. So there's a float valve. So under no pressure, the valve, the little float is down, allowing air to be emitted into the system in case there's a siphon. So here's a more engineer view of and breakdown of an irrigation valve. So again, the solenoid. So if you look closely, you can see there's an opening, and then it's called the plunger, which is inside the solenoid. So this blocks the water from being let go of the top of the bonnet. So when the electrical current comes, this plunger goes up and allows the pressure from the top of the valve to go out the downstream or towards the sprinkler side and allowing the valve to open. We have the diaphragm, which is the center rubber component. It's basically pinched between the bonnet and the body, which is the bottom part. So this is the traveling, basically the door that opens and closes and allows water to come in to the irrigation zone, to the sprinkler side, or to stop it and seal, allowing the valve to be at rest and closed. So we have 2 ports, one at the bottom of the diaphragm or on the side of the diaphragm, and then another port on the solenoid. So this is where water travels through, either allowing the valve to turn on or turn off. So we have external bleed valves. I cover that in different pictures as well, but basically the external bleed valve is a knob that we can turn. We do a quarter turn. Water will then start seeping out, and that's allowing water to evacuate the upper part of the bonnet and allow the pressure on the bottom of the valve to open the diaphragm. And again, that's the control valve. So that's the cross on the top. Again, the bonnet is the upper portion of the valve seat. So at the bottom of the diaphragm, there's a rubber seat, which sits along the body of the valve itself. And that's what keeps the water from seeping through. So if there's a damage to the seat, whether it be on the diaphragm side, the rubber side, or damage on the valve body side, on the valve seat, the valve will either stay open or it will continue to leak. And we'll cover that when we cover troubleshooting. And that's how the water travels through this valve in particular. Water comes in. So this is the side that's connected to the water meter. Constantly under pressure, water then travels through a port in the bottom of the diaphragm, stays in the upper chamber, and then when released, water is able to flow through the valve. So I created this video this week of breaking down. So hopefully this will give you a little bit better visual terminology.
First part of the valve that we're going to talk about is the solenoid. Solenoid can easily be replaced by turning in a counterclockwise manner. As you can see there, that comes off. This is the electrical component. You want to check the port, make sure that's nice and clean. Second part is the bonnet. So the bonnet can be taken off with a screwdriver. As you can see, that's the upper component that comes apart. Now that the bonnet's off, we want to look at the diaphragm. So the diaphragm is the rubber component that sits between the bonnet and the body. The part that has the most mobility, tends to wear out over time. And we want to look at the valve seat. So this is where the diaphragm seals on the bottom of the body. I like to run my finger to make sure there's no nicks, that it's nice and smooth. And I also want to run my finger around the rim where the diaphragm meets with the body. So now we can reassemble our valve, putting the diaphragm in place, assembling the bonnet. One very important thing when putting a bonnet back on, we want to tighten in what's called an X pattern, going on one side of the bonnet to the other to make sure there's even pressure around the bonnet. Once everything's nice and neat and tight, we're ready to turn the irrigation back on.
Okay, so hopefully that was helpful. That's a big part of this class, is everybody's able to tear apart a valve. So when it comes to valves, the part that we can replace is the solenoid. I'm going to cover how to check that later on with the multimeter. But the diaphragm can also go bad over time. The valve can either stay on again or leak. So you can't replace that. Depending on the type of valve you have installed at your residence, or let's say if you're managing a site, depending on the brand and the model, some replacement parts are a lot easier to find than others. So here's an example. So this was a picture taken at one of our evaluations. This is the valve that I took apart. So when the valve runs, water is leaking from this part of the diaphragm. So where the diaphragm meets with the body, underneath there, the diaphragm just worn out in that spot, and it's causing all that leakage. Following the steps that I went through, you would be able to take off the bonnet and replace that diaphragm, put it back together. One thing I didn't mention in that video is whenever we're working on the irrigation valves, especially on the mainline side. So the side where the solenoid and the bonnet are, you have to make sure that the water is turned off to that section. Either you have a shutoff valve that will shut off the irrigation or isolate the irrigation, I should say, from your residence. Or you would have to turn off, call the water utility to shut the water meter off, because if you did undo this or take the solenoid off when the water is still live in your system, you will be soaked very, very quickly. And it will not be a pretty sight. Right, so here would be this is the isolation shutoff valve, where they would be able to shut that off and then have the water in the whole entire system. Here was in a replacement valve. So this was a newer valve. These are brass adapters. So they still are anti-siphon because of the body has the anti-siphon. In my opinion, it's always best to replace like for like, meaning you replace, if you need to replace a valve, you replace it with what was already existing, just to have continuity and to have everything be uniform. Okay, and before I get to repairs, I think I have a couple questions. Let me get to those before we move on. Okay, so I have from Brianna. So it said, how would you know when there is an issue with your valve? Are there any indicators to look for? Great question. We will definitely be getting into that. I'm going to do a step-by-step diagnostics of the irrigation valve. So please hold me to that question. So if I cover the next section of slides when we get into repairs, if you have a specific question and I did not get to it, please type it into the chat. Or if by me going through it, it sparked a new question, please feel free to put it in the question and answer, but great question. Okay, so I have another one. It says, I have a leak from the pressure release portion, forgot what you called it, of the valve. Is this normal? The pressure release portion. Okay, so where you can, the bleed screw or the external bleed screw is what I'm thinking. Yeah, that should not be leaking constantly. So those are typically, depending on the type of irrigation valve you have, but typically they're plastic. So it's plastic on plastic. So I always recommend to not use the external bleed screws that often for that reason, that they are plastic on plastic and they usually have an O-ring. And if you are constantly opening and closing them, they tend to leak over time. So if you do have it leaking, there are a couple options. I would terminate the water pressure to that system and completely. So hopefully in your manifold, which again is a grouping of valves, there's a shutoff valve. If you're able to turn the water off, so there's no water pressure, I would take that screw completely out and see if it's if there's any damage to it. I've seen them just snap in half, which you would have to replace the valve. I've seen it where all it is just a little O-ring that sits underneath it, where you can just go to any hardware store and get a little, 10-cent little rubber piece, screw it back in and it'll seal. And the issue with it constantly leaking, that's allowing the diaphragm, so the moving component of the valve, to not be completely closed. So there might be water seeping into your irrigation system. Indicators of that would be, let's say you have one sprinkler that looks like it has a lot of green moss, or let's say that water is just barely leaking out of it and it looks like it's constantly moist. That's an indicator that your valve is not closing completely. So if that bleeder screw is leaking, so the external bleed screw, and I think that's what we're talking about. If that is leaking, I mean, I would even go and just try to turn it like maybe an eighth of a turn, a quarter of a turn tighter to see if it'll stop. Because if that is leaking constantly, there's a possibility that the valve is not closing either. And at the end of this presentation as well, I'll have my email. So if there is a specific question you have, I mean, pictures go really, really a long way with me because we are not able to go out to people's residence right now. But if send me a picture, I could definitely answer questions more in depthly. But thank you for the questions. So when we're talking about troubleshooting an irrigation valve, we want to use what we call the process elimination. So there's only 3 possibilities of valve malfunction, whether it's hydraulic, mechanical, or electrical. So what does that mean? So hydraulic means that there's something impairing the flow of water. So that means typically that's something from the water meter to the irrigation valves themselves. That would be something that's slowing the flow of the water to the irrigation valve or completely stopping it. Mechanical, so something that is physically stopping the valve from functioning properly. So mechanical is usually something to do with the functionality of the valve itself. And then electrical, so there's something wrong with the valve's solenoid, the wiring, or the irrigation controller. It could possibly be that it has nothing to do with the valve and it's the irrigation controller. And we'll go over how to check these. So the 3 possibilities: hydraulic, mechanical, electrical. So let's say the valve stuck open. So the valve stuck open means that it's constantly running. It's not closing when it's supposed to. We're not sending any power to the solenoid telling it to open. It's just constantly leaking. So this could be partial leaking to where the valve's not completely open, but it's leaking, it's seeping water into our system, or there's an obstruction and water is continuously flowing. Valve stuck open, this is like when you're driving around your town and you see the sprinklers running and it's like 12 o'clock and it looks like, you know, the Bellagio and there's just water flowing everywhere. That's probably somebody has a stuck open valve. So the culprits for this, incorrect controller settings. So again, controllers could be an issue. I've seen it where the controller, something went haywire on one zone and it's constantly sending power to the valve unknowingly. Worn or damaged diaphragm. So again, that's that center part. They do wear over time, especially if the valves are inactive for a long time. They can get very stiff, and then when you try to turn them on, run into issues like that. Debris in the valve. So you might ask yourself, how could debris get in the valve? Well, there could be something, let's say you're doing a repair, you cut open the pipe, you get some dirt in there. If somebody's doing work, let's say the city's doing a major repair and you know they do their best not to get any debris, but let's say that some debris gets in there. A lot of things can get into your irrigation valve. Loose solenoid or bleed screw. So we kind of covered that a little bit with our question, but our bleed screw is the external bleed screw. So that's the screw that we can turn to open the valve. That could be loose, and the solenoid as well. So a lot of these solenoids, you can see there's an on and off. You can twist by turning a quarter to half a turn maximum on the solenoid, and you'll be able to break the seal here and turn the valve on as well. A damaged valve seat. So that's where the valve sits on the body. So when I had the video of repairing that and opening it up, it's always good just to run your finger. So if, let's say, a small rock got in there and then the valve closed, if it pinches the rock against the valve body, it can get nicked and it will they wouldn't be able to seal. So then we would have a small leak, relatively small leak, but a continuous leak, which are the most dangerous. Insufficient force at the top of the diaphragm. So on top of the diaphragm, there needs to be, that's where the pressure builds up and forces the valve down. Sometimes the equilibrium is off because of the flow stem. That's a little bit more of an advanced troubleshooting, but. So weeping valve. So again, so this is the water that's slowly but constantly escaping from the lowest sprinkler head. So when we mean lowest, we mean if not necessarily that you have a slope or like you're on the side of a hill, but there's always a sprinkler head that's either at the end of the zone or just at the lowest level, because water always goes from high potential to low potential. So it always wants to go to that lowest area, and it will be seeping out. So if you have an irrigation, if you have a sprinkler head in your yard or in your garden, and it looks again to constantly be wet, not leaking a lot, but there's kind of mossiness, you might want to look at your irrigation valve. So culprits for typical of a weeping valve, damaged solenoid seat. So here, this typically doesn't get damaged, but it could. Damaged valve seat, again, that's where the diaphragm sits. That's pretty common because if any debris comes in and gets trapped in there, it's going to damage the valve seat. And then if there's any just debris in the valve. So possible culprits, the valve won't open. So the flow control stem is down. So the flow control stem can be turned up or down. So it basically limits the travel of the diaphragm. Most people don't really mess with it. It's usually turned all the way out and then turned down one time. But if turned all the way down, the valve won't open. So that has happened to me quite a few times, especially in commercial maintenance. Let's say the valve turned on and there's somebody that's knows enough to be dangerous and they don't want the water on, so they go and open the valve and then they turn it down. Let's say they were watching the stars at night on a blanket in the grass area. I don't know what they were doing, but they go and turn that off, so the valve turns off. But you know, a week goes by, 2 weeks go by, and it looks like the valve is not operating and not opening, but it was just that somebody turned down the flow stem. Bad solenoids. So the solenoids can go bad. They are also an electric component. You can think of a solenoid as just a bunch of copper wire wound really, really tight. So when that power goes, it creates a magnetic field that pulls that plunger up. So just like anything that's electrical, it can wear down. They can be shorted out. So if the valve won't open, we can check the solenoid. And I'm going to go over how to use the ohm meter to do that. Ports can be plugged. So the port for the solenoid, and then also the port going past the diaphragm can get clogged. This does happen, especially if you have a lot of hard water. If you're pulling from well water, I know San Diego County has more issues with that. So San Diego County typically uses valves that have stainless steel components, internal components, to help with that. Solenoid not receiving voltage, so maybe the solenoid's good, but the wiring connecting the irrigation controller to the solenoid might be disrupted. So it could be a broken field wire. So the wires that are connecting the irrigation valve to the controller itself could be damaged. This happens in a residential, it does happen. Commercial, it happens a lot more often. But let's say you're renovating your planter bed and you didn't really know that the gardener had run the wires from your irrigation valve to your controller in that planter bed, and you just chop it to bits. Trees expanding, or even even large shrubs, the roots can pull apart the wire over time. But more often than not, it's going to be a bad connection, which is the wire nuts, which I'm going to talk a little bit more in depthly, or it could be the controller not working properly. Okay, so if the valve won't open, and we know that it won't open, one quick test you could do is you can open either the internal, which is turning the solenoid, or the external, which is the bleed screw. You can open those up, and that'll tell you a lot. So if you're able to turn your bleed screw, either one, turn that and the valve turns on, and you can visually see the irrigation system operating, then you know that the issue is not hydraulic and it's not mechanical, right? Because the valve operates and there's water flowing, so it's not a hydraulic issue. So that eliminates it, and you can say, okay, it's electrical. The same thing can be said if I turn the bleed screw and water starts trickling out, and then it kind of slowly stops and the valve never came on. Well, more than likely you have a hydraulic, your hydraulic is good, but maybe it's a mechanical, that the valve is keeping itself from being closed or being open, sorry. Also can be said for hydraulic. So if you have another valve next to it and you're able to turn the valve on next to it, it's not going to be a hydraulic issue, so that valve has a mechanical issue. So turning the bleed screw kind of tells you, gives you a head start on where to look. So yeah, using the external manual bleed, so the external bleed screw, no water to the valve, no water from the bleed port. That means it's a hydraulic issue. Flow control turned down, water from the bleed port. So if the flow control is turned down, water would still come out of the bleed port, but their valve would not open. And then also it could be an issue with the diaphragm. So it could be too stiff to move. So again, if you have a valve that's inactive for a long period of time, that could cause it to get stiff and not want to open. So you would need to replace the diaphragm. I'm checking to see if there's any questions before I get into solenoid diagnostics chart. Hopefully everybody's following me on this stuff. Please, if you have any questions, there's no bad question. I'm here for you guys. That being said, solenoid diagnostics. So I'm going to talk about using an ohm meter, so a multimeter set to resistance or the ohm setting. So when we get our readings, which I'll show right now how to do that. If our reading is 0 to 6, the solenoid is shorted and we need to replace it. If it's 6 to 15, it's a slow burn, draws excessive amps. Also needs to be replaced. If it's between 15 to 50 ohms, it's a good solenoid. I would expand that to closer to 100. Ohms maximum is a good solenoid. Different manufacturers just essentially have more copper than less copper. And the higher the copper content of the solenoid, the larger the ohm reading or the resistance. So anything above that, there's probably a broken internal wire. So we would need to replace it. And then if we get an infinite sign or an open sign on our meter, it would indicate a broken wire or a bad connection. Right, so what does that even mean? So using a multimeter, so here's my multimeter. We see we have all these settings. We have the V, which is voltage, with the wave sign on top is AC voltage. We're not checking that. What we want to do is the omega sign, which is resistance. So basically we're checking that it sends a pulse, no voltage here, just a pulse. It runs down one lead, spins around all the copper wiring in the solenoid, and then comes out the other lead, and it gives me a value. And then this value, going back against that chart, will tell me if my solenoid is good or not. So this is a brand new valve, and the reason why I expanded the 50 to closer to 100 in my experience, and that's how I usually teach it. I just forgot to change this. This is a brand new solenoid, brand new valve that's never been installed, and it has an ohm reading of 43.6. So if you're a very analytical person, you're like, oh, well, that's close to 50, maybe I need to replace it. Not the case. Brand new solenoid. This manufacturer, the more commercial grade solenoids tend to have a little bit higher resistance. They last longer. They can handle higher voltage input. So for checking this, we can check it. Of course, this is on my patio where it's a lot easier to check it, but we want to take one lead, and it doesn't matter which one goes to which. On one lead from the solenoid, and then the other one to the other lead, and it'll give me the resistance value. So this is the utter chaos that ensues typically. So in on this picture here, so here's the common wire. So this is a typical, that we run into in residential. I'll talk about why this is a really terrible setup. I shoved the one into the common wire. So the common wire is a grouping of each one. There's two leads. I should start with that. Two leads on the solenoid. One of them has to go to a common, which is connected to all the solenoids in the same zone, or all the solenoids on the same controller. And then the other lead goes to the station wire. So that's where the power comes in. The common is kind of like a return, which is all is connected to the irrigation controller. So one goes to the common wire here, and the other one goes to the station wire. And see, I have a reading here of 0.2.3. So going back to that, this would be a shorted solenoid, and it needs to be replaced. And that is very true, that I need to help them out and do that for them. So before I get to maintenance, I have a question. Okay, I went too fast through checking with the bleed screws for the 3 problems. Okay, yeah, I can repeat it really quickly. And then also this is going to be on demand. So checking with the bleed screw, let me see if I can get back really quick. So checking with the bleed screw. So if you have a valve and it won't open, if the valve won't close, the water is running, that's a whole separate issue. So this is only using the bleed screw in the issue of if the valve won't open. So we want to turn the bleed screw and then observe. If water is coming out of the bleed screw like it should be, and the valve turns on, normally we're able to see the sprinklers pop up or the drip run or whatever it is that we have on that zone. If we see that come on, then we know that I want to start checking for electrical issues. Because if there's water coming through the valve, that means that the hydraulic system is working and that mechanically the valve is working, right? So the third component to that would be electrical. Easy enough for that one. Then you start going through the protocol of checking the solenoid and the wires and things like that. When it comes to turning the bleed screw, and it's water's continually coming out of the bleed screw. So just like normal, water's spitting out of that, and yet the valve doesn't open, and the bleed screw continually has water coming out of it, that means that there's more likely a mechanical issue with your valve. So there's the hydraulic portion, so the water's coming in nice and smooth. It's coming out of the bleed screw. It should open the valve, but yet the valve's not opening. That's when you want to start looking at mechanical issues with the valve. And then lastly, if you open up the bleed screw and water starts to come out of the bleed screw for a couple seconds, let's say, and then it trails off and it stops, and the valve never opened, and then the water ceases to come out of the bleed screw, I would start checking at a hydraulic issue. That means that there's not enough water coming into the valve to allow it to open. Hope that cleared that up. So I'm going to cover the maintenance and then I'm going to take a break. So if there's any other questions. So I put no ongoing maintenance with the irrigation valves. When I talk about drip irrigation valves, the added component of a filter, we'll talk about maintaining those. But as far as maintenance, there's not really an ongoing maintenance like there is for irrigation, pop-up sprinklers, and drip systems. So before I get into that, I'm going to go ahead and take a quick 5-minute break. So if there's any other questions or comments, please put them in at that time. I will address them as we start getting into overhead irrigation. Okay, I am back. Not sure if I took the whole 5 minutes, but I'm going to take this opportunity to hopefully answer Pat's question. So you said, which irrigation system is better, PVC or black plastic pipe? They use black plastic pipe here in Las Vegas, and mine is 17 years old and is getting past due. Which should I use and how deep? It does occasionally freeze in winter. That's a great question. So the reason why they use black plastic pipe, or it's called poly pipe, in areas where it does freeze, is that pipe is actually able to expand when the water is inside of it, where PVC pipe does not. So you have to go through a protocol of what's called winterization. You have to basically run your irrigation system, and a lot of times they connect an air compressor, and forcefully blow out the water, so the pipes do not expand and break. So 17 years, yeah, that seems about right with poly. I don't have a ton of experience with poly pipe, but as far as freezing, I would be curious to know how deep the frost line is. Here, typically we put the irrigation pipe for the main line, a minimum of 18 inches down, and then for the lateral lines, you want to go down about 12 inches, so about a foot down to 18 inches. I don't think that would be deep enough for an occasional freeze. So I'm not sure. I could look into that. If you want to send me an email, I could look into that and get back to you, because honestly, I've never dealt so much with freezing, and that'd actually be something I'd be curious to look into, as far as how deep you need to offset that. So Pat, if you wouldn't mind at the end, when my email comes up, if you want to shoot me an email, I could give you a more technical answer with that. Thank you though for the question. Okay, so overhead irrigation. So what do we mean overhead irrigation? So that's just a category of either pop-up sprinklers, rotor sprinklers, essentially any irrigation system that throws water in the air over the head of the plants and water comes. So best suited for turf and low growing ground cover. So taller plants can block it. And we, again, if you go to our on-demand classes, I cover this more in depth. So for this, I want to talk about parts breakdown, something I didn't necessarily cover in our irrigation basics, just so we have the terminologies down. So we have the nozzle, which is on top of the riser, which is the part that pops up of the sprinkler. Wiper seal it's typically white, but it is the seal, the rubber seal that goes around the riser as it comes up. It seals so water doesn't spit out. This is why when you turn a sprinkler on, before the stem is completely engaged, you'll see a lot of spillage in this area. It's because the wiper seal is designed to seal when the sprinkler is all the way engaged. The cap is the removable part on the body. So this screws out. So these do either crack or they have a seal where they will leak. And then the body, and then the inlet where the water is, where the irrigation, the sprinkler piping is connected to. Same thing, so this is a rotor. The nozzle is inside. The riser is still the same component. The wiper seal, the same area around. The cap is the same body and inlet. All right, so here's a typical pop-up overspray, overhead spray. This is a rotor nozzle, so it has one large stream and it articulates back and forth. Here's a nozzle on a solid riser. all still considered overhead irrigation. So I'm going to talk a lot about uniformity and why that's such an maintenance issue. But before that, I wanted to talk about choosing the right nozzle. So choosing the right nozzle is really important. So it's usually hard to see the number on the nozzle itself, but all the nozzles have a number. So indicating if it has a number 8 and an H on it, it is 8 feet. So in each direction, it shoots 8 feet from the center. And an H means a half, so 180 degrees. So this is going to shoot a semicircle 8 feet in every direction. Same thing with a 12 or 15. Typical ones that we see in the home irrigation, especially in the lawn areas, is an 8, 10s, 12s, and 15s. So that means in any which way it's watering. So I usually run into, especially in the home irrigation, the kind of hodgepodge of different distance. So throws, we call them throws in the industry. But so even though the sprinklers are spaced out 10 feet apart, I might see a 15-foot nozzle in one sprinkler, and then adjacent to it, I might see a 10. So we have a lot of water doubling and overspraying in that area. So we only need a 10-foot nozzle. They'll just throw in a 15, vice versa. So that's something to look at, especially if you need to replace your nozzles. Just get a tape measure. Get a tape measure, measure from one sprinkler head to the next, and then that'll tell you what size nozzle that you need. So for more high efficiency nozzles, you might hear that term being used. We have rotating nozzles, which instead of being one, what we call a fan spray, where there's just a big fan of water being applied, it has multiple streams and it rotates. And then Precision, this is another Toro is the manufacturer of this. It's a regular fan spray nozzle, but they have this little smart chip in there that rattles the water back and forth, and we were told that it saves water from less misting. We have fixed sprays, so they water either a 90, a quarter, a half, a full. So whatever it says on the nozzle, that's what it sprays. And then we have what's called a van nozzle or variable arc nozzle. Very popular nozzle. So you can twist the upper cap and you can turn it from essentially a 270 degrees down to a 90 degree. So if you had odd shapes or you don't know which nozzle to replace, you can just put this nozzle in, adjust it to where you're hitting only plant material. Then really quickly, just the gear rotor. So these usually cover a larger area, have one solid stream, and then they articulate, which is set by the user, whether it's a quarter, a half, or a full. And again, I'm not going to cover this too much, but the rotating nozzles, they can just be replaced on the regular pop-up for the majority of the brands that you already have in your irrigation zone already. And then there's rebates available through your water utility, depending on where you live. So I'm just going to show really quickly how you can adjust these rotating nozzles.
The nozzle itself has a fixed arc on the left side. On the right side, it is adjusted by moving the little silver ring on the very top. If you turn the ring counterclockwise, it will close the spray, reduce the arc. By turning it to the clockwise, it will actually open up the spray, giving you a wider arc.
So you can see how adjustable those are. So that's considered a variable arc nozzle, but that is the rotating nozzle. So they have that capacity too. So let's say we need to replace a sprinkler. Let's see how we can replace a sprinkler.
Hi, this is Brandon with the WaterWise Community Center. This is going to be part one of a two-part series on how to replace a sprinkler. So the first step is identifying the sprinkler that we want to replace. And for now, the only tool we need is a shovel. So let's start digging. All right, so now that our hole's dug, our sprinkler is easily accessible. You might need a pair of channel locks. And in this case, since I dug such a nice hole, you can just spin the sprinkler off. We're ready to put in our new sprinkler. Now that we made sure we had the right sprinkler that we need to replace our broken sprinkler with, we just simply screw in the sprinkler and start putting the dirt back. And that's it for part one. Hi again, Brandon with the WaterWise Community Center, and this is part two in our series on how to replace your sprinkler. One of the important things while setting our sprinkler back is make sure we compact the soil around it. Make sure that the sprinkler is up straight. The sprinkler that we installed has a flush cap. Flush caps are great. They allow us to run the system, get out any debris, anything that might have got into our line when we're making the repair. Last step, removing the flush cap. And I just took the nozzle out of our broken sprinkler because the nozzle's still good. Simply screw the nozzle in. And so that's it. Thank you for watching this two-part series on
Okay. Again, thank you all for attending this virtual hands-on irrigation maintenance class. So for maintenance, one of the issues I had mentioned is water pressure. So water pressure at especially a fixed nozzle is really essential. So a fixed spray nozzle like this is designed to operate its most optimal. So it's if it's a 12-foot nozzle, it's going to go 12 feet. There's going to be less misting. So misting is when there's too high pressure and it causes almost like a fog when the sprinklers come on. That ideal pressure is 30 psi. 30 psi, it seems pretty low in all actuality for your entire zone to be operating at 30 psi. Is a little tough. This one is operating at 50 psi. This is a pressure gauge that you can get online. This is the Hunter brand. You just unscrew the nozzle. This screws into the riser, and then the nozzle screws back on top. And so you're able to operate your system and see what pressure you're at. State of California now has mandated that all sprinkler bodies have to be pressure regulated. So now there's sprinkler bodies. Let me go back so I could show you a sprinkler body really quick. The sprinkler body actually has pressure regulation inside of it. So there's a pressure regulator that goes underneath the inlet, and then that's going to keep 30 psi after that regulator. So your whole system could be at a higher pressure, so you can have everything operate properly. And then once the pressure gets into the body, past the inlet into the body of the sprinkler, it'll be reduced to 30 psi, allowing this nozzle to work most optimal. So that's always been an option, for, I don't know, the last 10 years or so. However, in the commercial settings, commercial landscape, being installed, they typically install pressure regulated irrigation sprinkler. However, for repairs, because it does cost, I think, an extra $1.50, people tend to just put the standard irrigation sprinklers in. So moving forward, I know that was initiated in January of this year. But it's still, they're still working through a lot of stock that a lot of the big box stores and commercial suppliers have of the standard bodies. But moving forward, all the irrigation bodies, all the pop-up bodies that we buy will be pressure regulated. All right, so this would be closer to 30 PSI. So is there a problem here? So there's no nozzle in here. This needs to be a more concise stream. The top part of this rotor is beat up and the seal is leaking. So 3 things going wrong there. Here's a more exaggerated picture that I took where this would flood out immensely because of the cap at the top was leaking. Here's another rotor where the cap is leaking underneath, and it was causing so much turbulence and causing an immense amount of irrigation leakage. And this was behind a big shrub on a large property, so this really wasn't that visible, although you can see how much of that is actually leaking. And when I talked about high pressure misting, this is a perfect example of that. So you can see that the water has such a high pressure that the water is not landing on its intended target. So the shrubbery here, it's misting. So up to 30% of that water is evaporating and it's just misting and moving off site. So why does this all matter? So irrigation system performance. So there's a more technical test that I'm briefly going to cover called distribution uniformity test. So what does that mean? That's a big word, right? Distribution uniformity. So basically it's how evenly the water is distributed over our zone. So our zone, meaning our landscape situation controlled by that irrigation valve. And a lot of the time we have non-uniform, so we can see under the surface, we have some areas that are getting way overwatered and some areas that are barely getting watered. So how can we test that? So one of the tests that my team goes out and performs when we run into a situation, typically in turf situations, we do what's called a distribution uniformity test, and it's called the catch can test. So these are all cans that we put out there. This can be done as simply as putting solo cups out into your lawn, spaced out between 3 to 5 feet apart in a grid, and you run the system. So all these cans are going to capture, and then we start doing some math to it. This is what it looks like for pop-ups as well as rotors. So rotors, they cover a larger area, they're more spread out, but typical pop-ups in the front lawn, we would have catch cans out like that. And so that'll tell us how evenly the water is being distributed. And the reason why, again, I'll go back to this picture here. The reason why it's important to calculate that is we need to know why or how evenly it's being distributed, so we know how long to run the irrigation system, and then also if there's any repairs and tune-ups that need to happen. So the situation like a non-uniform where it's unevenly watered, here where we would probably have a brown spot, here in this other low moisture area, we would have another brown spot. We would see these inefficiencies, and the typical thing we would do is, oh, we need to put more water. So I've seen a lot of areas over the summer, especially over the last month, where we were having 100 degrees day in and day out. We started seeing a lot more brown spots pop up in people's lawns. And it's not because necessarily that they're not running their irrigation system long enough, it's probably they have low distribution uniformity. Those are the areas that don't get quite enough. Well, some areas are getting way more than they need. So what causes low distribution uniformity? Well, tilted sprinkler heads is a huge one in my experience. So the sprinkler head not being parallel with the soil, maybe it's sunken on one side, or somebody has kicked it, or when they mow the lawn, it's the soil's too moist and the heavy mower runs over it and tilts it. Plant interference, that happens as well. So the plant grows too tall. Let's say if it's some sort of shrub and it blocks the water coming off the sprinkler, or even if the pop-up is not tall enough for the grass that's growing, or maybe they didn't mow for a couple weeks and the grass is blocking the sprinkler from covering the area that it needs to. Mixed nozzles and equipment. So like I said before, if we need a 12-foot nozzle to cover from one sprinkler to the next, and they have a 10-foot or an 8 because that's all they had on their truck, or that's all we have in our garage, there's going to cause areas that are going to be watered much less. Sprinkler spacing. So if the sprinklers are not properly spaced, maybe one's 10 feet apart and the other one's 15, we need to fix that spacing, and I'll go over how to do that. Incorrect pressure as well. So how do we space out our sprinklers? So equal spacing, our goal is head-to-head coverage. So meaning that this sprinkler head, the spray hits the next sprinkler head. So if these were 12 feet apart, I would want a 12-foot nozzle spraying 12 feet and hitting the sprinkler, because the sprinkler is not really designed to water really close next to itself. It's depending on the sprinkler next to it to water close to the cap and the body, the sprinkler itself. So in a perfect system, we would have perfect uniformity where this is a quarter watering, hitting that head and that head. This is a half. Sprinkler would be watering, hitting 3 sprinklers. This full here would be doing a full circle, hitting all 4 sprinklers. That would be perfect head-to-head spacing. And when we design an irrigation system, we try to get that as best as possible. So we don't have proper head-to-head coverage. So here's a better illustration. This sprinkler is only reaching halfway. This sprinkler is only reaching halfway. We have too much water in the middle, and then we have dry spots surrounding the sprinkler itself. Where if we have good head-to-head coverage and correct spacing, this sprinkler is hitting around this sprinkler is hitting around this sprinkler, and then the middle, they share the load and everything's evenly watered. So how do I know if I have correct sprinkler spacing? So we want to start with the corners, add head as they're needed for head-to-head spacing, use the sprinklers with the longest radius to minimize the number of heads. That meaning longest radius is the largest gap that we can install to minimize the number of sprinkler heads we need. So the size of sprinkler is limited by the width of the area and the system hydraulics. So we can only put so many sprinklers on one zone depending on how big our area is and how much water we have available. So just a basic square design just to get the idea. So if we measured from the corners and we say it's a 20-foot spacing, and we want to use rotors, for example, a full circle head uses 8 gallons per minute, a half circle head 4 gallons per minute, and a quarter circle 2 gallons per minute. And these are just whole numbers just so we get the idea. Depending on the manufacturer, they will tell you the exact gallons per minute used per nozzle. So if this is our area, we would need one full in the middle, going 8 gallons per minute. For the halves, we would have a half here doing 4 gallons per minute, a half here going 4 gallons per minute, a half here going 4 gallons per minute, and then another half going 4 gallons per minute, meaning it's going to do a half circle here. This is going to water, hit these 3. This is going to hit those 3. And then a quarter, 2 gallons per minute here, a quarter here. So when we mean a quarter, we mean 90 degrees, so it's only going to be watering here. So this entire area is 32 gallons per minute. And the reason why the quarters are giving, when it comes to rotors, so this is an example of a rotors, 2 gallons per minute, it's because they all turn at the same speed. So a quarter is gonna go back and forth 4 times before this full does 1 revolution. So this one needs to be watering 4 times as much because again, the timing. So they all operate at the same speed. So this is gonna go back and forth 4 times before this is going around once. And the same with the half. So the half is gonna go back and forth twice as fast as the quarter, but half the speed as the full. So this one would be, we would put in a 4 gallon per minute. All right, so what about if there's odd shapes? So this is a typical landscape design. You know, we don't really have a nice square area. You know, we want to have some nice curvatures and things like that. The process of starting in the corners kind of doesn't work here. So this is when spacing and grouping, the idea is still going to be the same. The sprinklers need to be the same distance away from each other. That's how you would kind of go with odd looking shapes. Still use the grid method and keep things evenly spaced so that we know which type of nozzles to put in, but just a rough grid spacing. So I said tilted sprinklers really mess up your distribution uniformity. So this is a step-by-step. If you do have a tilted sprinkler, you need to dig out a generous amount around the sprinkler so that you have a little bit of room to adjust. So here's the rotor. This is the adjustment tool, so I can change the arc. So you want to really, if you're going to dig it out, you want to make sure that you have it nice and straight. You can use a level if you want. Once you have it set, you want to put the soil back because we need to compact it to hold it in place. Taking your shovel and kind of mixing it up so it's not so clumpy is a good idea. And then as you're going, compacting the soil with your boots, making sure that the sprinkler is still up in the right position. And this is the part where it takes a little bit of time, but you really want to compact around it. Make sure that it's level again, and then you want to run it. So I just put a couple cans out there as this ran to see if I got it more evenly to distribute. Then I have one more quick video on fixing a sprinkler and changing a nozzle. The first step is knowing that you have an issue in your landscape. It's finding a dry spot. The next step is turn on your irrigation system. And we have a clogged nozzle that seems tilted, as well as a sprinkler that's turned. So the arc is hitting more concrete than it is landscape. So to adjust the sprinkler, we want to turn the system on and then get our pliers out. Once we have our pliers, we want to gently grab the stem, gently turning to make sure that
all the water is hitting the landscape and not any of the concrete. So to replace a nozzle, you want to pull up the stem, unscrew the nozzle. Oh, we can see this one's clogged here with, seems to be quite a bit of debris. So let's go ahead and replace this nozzle. You want to put a filter in and screw in the new nozzle. Another thing we want to make sure is that this one is going to hit only landscaped area.
Okay. Okay, I had one question. So where you can go to access the presentation is going to be cbwcd.org/presentations. So it's our website. There will be a PowerPoint or the PDF of this PowerPoint, and then our YouTube channel, cbwcd.org/YouTube, and you'll see the live stream there. Okay, so we have two more topics. We have drip irrigation, and then we will cover irrigation controllers. So for drip irrigation, we want to start with the valves. So the difference with a drip irrigation system is we have the standard anti-siphon valve for residential irrigation. And then we have a filtration system, as well as a pressure regulator connected on the downstream side. So this is the sprinkler, or well, the drip irrigation side. So the sprinkler side of the valve. And so the reason why we need a filter for this, for a drip system, it's pretty simple. So drip irrigation uses low volume, really small orifice emitters. So these emitters that allow the water to seep out of them, to drip out of them, are very, very small. So we need to have extra protection, because if those get clogged, they're sometimes difficult to become unclogged. So we have a filtration system that goes right after the irrigation valve, and that helps protect against unwanted debris, as well as the pressure regulator is key for this. So 30 psi pressure regulator is standard. It's because we don't use any glue on our tubings, and our emitters require that low flow or low pressure to allow that low flow of irrigation water to move through. This is a brand that's not necessarily brand specific, but this is a Rainbird. It's a 2-in-1. So it's a pressure regulator as well as a filter in one piece. So you might see some of them where there's two, like our previous slide, where there's a pressure regulator, and then there's the valve or the filter after the valve. This is a 2-in-1, which is handy in a lot of situations because you don't have that much room after the valve before it goes into the ground. And it needs to be accessible, the filter, so that you're able to maintain it. We recently did a specific drip irrigation class. So if you fancy drip irrigation, again, go to our YouTube channel to see the live stream of that presentation. So filters are 200 mesh filter. So that's the type of the filter. Water passes through the filter, collects small particles, and filters need to be cleaned twice a year. So you don't have to shut the irrigation system off to clean out these filters, because they are on the sprinkler side of the valve. So there's no pressure going through it. Simply unscrew it, take out the filter. As you can see here, don't use any air compressor or any forced air into it, because you can open up those pore spaces, which we do not want to do. Just run it with some clean water make sure you clean it out twice a year. So that's what it looks like coming out. So that just fits right there in that orifice with a cap on it. So some of the drip parts we're going to talk about when we talk about repairs. So these are insert couplings, these are insert tees, insert 90s. This is the figure 8, which you can use at the end of your line to seal the tubing, and then drip staples. So again, if you want to know more about drip, look on our YouTube channel. So here's a picture of drip tubing. So this is subsurface, it's exposed here, but this is under DG. So here's a broken fitting. So you can see, even though it is drip and it is low flow, it can flow quite a bit of water when broken. And one key for doing maintenance when it comes to drip irrigation is always keep extra parts, because even though again, they are low flow, a lot of times these are either under mulch or they can easily be stepped on and the parts can be broken. They are plastic pieces. Always have extra parts on hand for maintenance. So here's an area that we converted from drip irrigation to drip irrigation, or from overhead irrigation to drip irrigation. So here's some tools, handy tools. So this is particular to the Rainbird brand. This is a really helpful tool that locks into the insert fitting, because even though it is small and we're not using any glue, it is a little bit tough to put those fittings into the tubing. What you can do is you can have some warm water on hand. You can put the tubing in warm water to soften it up a little bit. During the summer, you can just leave the tubing out for a while exposed to the sun. It makes it a little bit more malleable. Or I've seen and heard, I haven't seen, but I've heard of people having a small blow dryer or something like that to heat the tubing up, so it can easily slide over the insert fitting. So it is barbed, so it won't come back apart. Here's the cutting tool, a mini sledgehammer, and stakes. In this example, we do have a lot of rocks here at our Waterwise Community Center demonstration garden. We have a lot of rocks in the soil, so this might seem like overkill, but in our case, it is not. So I'm going to show a quick drip repair video now.
Drip irrigation, especially when it's covered by mulch, it might be a little tricky to find a leak. So the first thing we want to do is, when we know we have a troubled area, is pull back the mulch with a rake. It seems like we found a pretty clean break right here. So tools that we'll need for the job is some insert couplings, some staples, a mini sledgehammer, and a cutter. So taking our insert tool, we put the coupling into the tear, make sure it's pushed in all the way, and then simply put the two pieces of pipe together, wiggling back and forth, make sure it's nice and tight. And to make sure that this is gonna stay, we wanna put a staple in with our mini sledge, hit it till it's nice and firm, not too tight to pinch the tubing. Once we're satisfied that the leak is mended, go ahead and take your rake, cover the tubing back up with mulch. Everything is good.
So you can see a lot of issues when it comes to drip and drip tears, or replacing of fittings. a lot faster, I would say, than having to dig out and glue the pipe and make those repairs. But in my experience, drip irrigation has more issues as far as maintenance. So you're doing it more often, making these minor repairs more often. So one very easily forgotten and very important with drip irrigation is to flush the valve or flush the filter, right? Not in the toilet, just flush it. And here's another breakdown. Simply unscrew the cap and then pull this out. Here's another brand of Netafim, another option, pressure regulating and filter. This one you could unscrew the upper cap and flush out, as well as open it up and take the filter out as well. So you can see, we want to make sure it's nice and clean. And we also want to make sure that we have these filters are accessible. So here we have 3 in a row. We can easily open up each one of those without having to disturb any of the other valves. The easier it is for us to maintain and the easier we make it on ourselves, the more likely we are to actually maintain. So running our drip system, we can set a manual run on our controller, or we can turn on at the valve, either by the internal bleed of turning the solenoid, or the external by opening the bleed valve there. And we want to walk our system. When it comes to drip maintenance, a lot of times we just got to turn the zone on and walk the zone. Small tears, you might hear a little hiss. It's not always a catastrophic break of the tubing and a puddle forming. So very much a look, listen, and feel around when you have drip irrigation, especially if it's either subsurface under the soil level or just covered and topped with mulch. Another flush valve. So this is going to be installed in your irrigation, your drip irrigation system, typically at the end of the line. So this is an on-off valve. So we always want to flush the tubing as well. So here's my coworker Daniel. So he's opening up this and flushing the zone. So even though we have a filter at the valve, it's always good practice the same time that you flush the valve on the irrigation valve, flush that valve. Also go to your system and flush the system, just in case there's any debris. If you do it at the same time twice a year, you're ahead of the game. I'm gonna play this video, and it looks like we have some questions. We'll get to them after.
Hi, this is Brandon Burgess with the Chino Basin Water Conservation District, and today I'm going to be sharing some water-wise tips for Fix-A-Leak weeks. Today's water-wise tip is how to look and listen for a drip irrigation break. Let's go ahead and turn on our system and see what we find. Okay, now that we've turned on our system, we walked around and we hear in this area, something that sounds a little different. This is where we know to start looking for the leak. Because drip tubing is typically covered in mulch, we can't visually see. So as we peel back, we found a leak. This is a tiny tear in the tubing, which could easily be done with your shovel when you're out there gardening. But since it's hidden underneath the mulch, we wouldn't have known unless we look and
Okay, perfect timing. Let's go ahead and let's take like a 2-minute break. And I got 2 questions. So if you have any questions, please type them in and we'll take a quick little break and then I'll come back and answer the questions. Okay, seems like we have two questions. I have one from Dale. You illustrate many types of sprinkler heads. I replaced many rotor and van style heads with MP rotating heads. They are much higher maintenance and must be replaced much more often than the others. Since you're using them in your demos, it seems the others still have their place in a water-wise landscape. Yeah, absolutely. So you're saying that the MPs are much higher maintenance. Yes and no. MPs can be a little bit more temperamental, I suppose. However, they don't necessarily need to be replaced as much, but definitely rotors, van nozzles, fixed sprays can be, when used properly, a very much an efficient system. So when it comes to just replacing nozzles with MP rotating nozzles, doesn't necessarily mean that your system is going to be water wise overnight. There still is going to be maintenance regardless. Sprinkler bodies can get tilted regardless if it has an MP or a van or any other rotor. Really, the key is understanding your irrigation system, the spacing of your sprinklers, doing the maintenance to adjust them, making sure that they're not tilted, that their arc hasn't turned, and they're spraying half of your sidewalk and only half of your turf. All these small little maintenance things really matter. And at the end of the day, having a system that has decent distribution uniformity, you're on top of how long to run it. So timing and how long you run your irrigation system is a huge aspect into that goes into if you have a water-wise system or not. Typically, in my experience of doing a lot of residential consultations over the last 5 years and doing commercial landscape evaluations for close to 10 years, the issues are usually the same. Not being on top of the maintenance, as far as, clogged nozzles, broken nozzles. I mean, I've seen systems where They have just standard pop-ups with standard fixed sprays, and it's the most efficient system that I've ever seen. And I've seen systems that have what we call efficient nozzles that are really poorly maintained and do a really poor job at being quote unquote water wise. So I think your comment, Dale, is pretty valid. So that doesn't necessarily mean if you change your nozzles, and I would argue that you're absolutely correct just by changing your nozzle or just changing to a smart controller that adjusts for the weather without proper maintenance and without proper know-how and want it to be water wise. It's very hard to achieve without that want. And so thank you for that. One question. Does reclaimed water have an odor, and do you use special precautions not to slosh onto your body? I mean, it can have an odor. It is, a slight odor. It does get on your body. It is not that big of a deal. It's more of if you digest it for long periods of time. So here at the Waterwise Community Center, almost all of our irrigation is recycled water, and we do repairs. We do a really good job at keeping the public from being in contact, so nothing runs during the day like we shouldn't be doing anyway. So doesn't necessarily have an odor. So and if it does get on your body, as long as you're cautious, I think it's fine. Okay, so last topic, irrigation controllers. So different types of irrigation controllers. We have indoor, outdoor. Indoor don't have the weather stripping. They sometimes don't have a upper cabinet box. Outdoor has, again, the weather stripping. It has a box that closes it, keeps the hardware from getting exposed to the elements. Residential, commercial. So residential tend to have less stations and have more basic features. And commercial have a lot more functionality, larger capacity, so we can hook up more irrigation control valves to it. And just really quickly, weather-based. So if you hear WIBIC, there's a lot of rebates available. And these rebates allow you to purchase or help with purchasing the purchase price of a weather-based irrigation controller. So this uses your local weather, landscape conditions, and equipment to determine your irrigation schedule. It'll adjust either up or down based on the current weather conditions. So in our area for residential, less than 2 acres, you have a available rebate of $80 towards getting a smart irrigation controller. And since the popularity and the price has gone down for Wi-Fi controllers, that gets you pretty close to that cost. Wi-Fi controller hooks up to your home Wi-Fi, allows infinite adjustability and information, weather information every single day. So for repairs, troubleshooting your irrigation controller, you want to check the obvious. I don't know how many calls I've had or times I ran into. The irrigation controller just wasn't plugged in, right? Oh, it's not working. I don't know what's happening. Everything's dead. Somebody came in and unplugged it and not knowing. And the reason why you might not notice that there's no AC power or there's no you can't tell that there's any power going into the controller is because they have a backup battery, and that backup battery keeps the time, the date, so the screen is still going to look the same. However, the battery is not going to be able to operate the irrigation control valves. You always want to check your programming, start time, run time, days of the week, Check for fuses. So some of the older controllers will have a fuse. Let's say that there was a spike in electricity and the fuse took the brunt of that and snapped. Now there will be no AC going to your irrigation controller. So always check fuses if you have them, and then check sensors. So a lot of residents now are having their weather controller, so like their rain sensor. If that goes, if it's wired, if there's a break in the wire, or if the battery goes out, it can impede your system from operating. You want to verify power, so use a voltage meter. So you want to check your voltage. You need 120 volts going into your controller. And then check the terminals where the irrigation control valves, where they hook up to. All right, so this is a Hunter, really popular home irrigation controller. Here is the backup battery. So this one has a 9-volt. So if there's an instance when there is no power, this will keep all your programming and your times and your dates. The terminal strip is where the station wires hook up to. The white is the common. So this is what connects all the valves together as they're returned. And then each of these terminals will have a wire connected to a valve. So this one goes up to, I think, 9. And one really thing in particular I talked about a little bit, but it's the wire nuts. So in a residential setting, wire nuts are really, really important. And what I don't necessarily see, like on this picture here, this was a commercial, but these are indoor wire nuts, right? So there's no weatherproofing, there's no gel, there's no silicate gel in there so that it keeps moisture out from your wire connection, because you have bare wires. The irrigation systems run on 24 volts, so it's not a high amount of voltage, but still we don't want any moisture getting into bare wires with that type of voltage going through it. And what happens is over time they corrode, the wires can burn. So all those issues will keep your irrigation valves from turning on. If you haven't in a while and they don't look that good, you can just simply go with your tools, your wire cutters, cut the wires, strip them till we have bare wire, twist them together, put a brand new weatherproof cap on there. I always at the irrigation manifold with a grouping of the valves for residents, I'll do new wire nuts, and then I'll wrap it in electrical tape, so I know that there's not going to be any moisture going in. So for troubleshooting with the multimeter, there's a couple things that you can check. So always look for the common wire, so the COM, C-O-M. So that's the return wire. The standard in irrigation wiring is that's going to be the white wire. However, in a lot of residential settings, that's not necessarily the case. Hopefully it is. That's one of the only standards that we have. And then locating the terminal strip that has the station wires that you want to look at. So here's an up close picture. So this is one of our controllers here at our center. So here's the common. This is a sensor jump. So we located the common wire. Here's our station wires. So we have 1, 2, 3, 4. So these are in what we call modules. These are connected to the valves. So valve zone 1, 2, 3, 4. So you can see this is a larger gauge wire because these are buried underground. So this is a 14 gauge wire. So you want to strip it when it goes in. So for me to check for resistance, so like I showed before, when we're looking at the solenoid, I just took the solenoid wires apart. I held one lead to one wire and then the other lead from my remote to the other. And I was able to check to see my resistance reading. I can do the same thing here at the controller, so I don't have to go into at the valves. I can check every single solenoid on this entire controller here at the irrigation controller. One goes to the common because every single one of these valves is connected to the common, and I stick my lead and touch the bare wire on each one of these separately, and I'm able to read. The other test I can do, here's a wider look here. The other test I can do is I can turn the irrigation controller on. I turn my multimeter to voltage, and I can check the output. So for this example, I'm checking the solenoids. So again, I'm able to check the solenoid all the way from the controller. One lead goes into the common, the other goes into the station wire. And I got a reading of 26.1, and that's ohms. So that's another way. If you want to just do some easy maintenance on your controller, open up your controller, clean out any, if there's any bugs, any dust, any debris. If you have a multimeter, turn it to resistance, and then stick one lead in the common, and then go to each and every zone with the other lead and check, and you can check the solenoids and check if there's a broken wire. Same example there. Another thing you can test is the output of your transformer. So every irrigation controller has a transformer. Let me go back to this picture here. You can kind of see it. But the transformer is up here. So the transformer takes the 120 volts that's given when you plug it into the wall. And then the output of the transformer is a nominal number of 24 volts. So it may be a little higher, but in a nominal sense, it's 24 volts. So 24 volts, and that's what the irrigation controller sends down these station wires when we tell it to. So if I say number one needs to come on at 4 in the morning for 10 minutes, when that time comes on the day, when that day comes as well, the 24 volts is sent to station one, and that sends power down to our solenoid. You can also check to make sure that the output is proper. I don't really see the transformers going out that often, so that's usually not the biggest issue, but you can check when turning your meter to voltage and connecting to the taps coming out of the transformer. Okay, so that's all I have. But before we go, I have an exit poll. So those of you still on this, I want to launch this really quick. And then during that time, also, I will answer any other questions, specific or otherwise, that you have. And my email is up on the screen right now. So if you do have any specific questions, or if a question pops up, feel free to email me at any time. And again, this will be live on YouTube if you want to refer back to it. And then I know we covered a lot of specific information, so a PDF will be available next week on our website for you to refer to. It looks like just about everybody. Poll. Thank you all so much. Okay, and I have a couple questions. Let's see. Oh. Okay, just some comments. Okay. So with that, if there's any, I'll wait a little bit longer if there's any other questions or comments anybody has. Seems like there's quite a few still logged in, so. If not, well, thank you everybody for being here with me on this Saturday. Hopefully soon enough, we'll be able to do these in person again. We can show off our beautiful demonstration garden and do some more hands-on demos. But thank you all for, again, for being here with us. And I hope to see you on another webinar soon. Have a great Saturday.